Hello, am I audible?
Yes, sir.
Yes, sir.
So, what we have discussed in the last class? Which question number we were discussing? Have you all got assignments? Had all of you got assignments? Class.
No, sir, I didn't receive.
I have given assignment. Actually, that is available on the portal, I think. So you can go there and after next day of class, it's available on the portal. Okay. So after every class, I give assignment and those are available on the portal. So previous class assignment is available on the portal. So you can download from there. Okay. So I think we were discussing. So here all of you present for NEET or some JEE. How many of you are for NEET? So others are for JEE. Who has raised hand? Samaira, you are preparing for NEET or JEE?
Sunny.
NEET. Krishna,
Sir, JEE.
JEE. Maharaj for JEE. Samaira, you, for which exam you are preparing for?
Sunny.
NEET. Okay. So we were discussing first we are discussing NEET question, then we will discuss JEE questions. So I think in the last class we had discussed till question number 15, right? If you remember, you can see your notes. I think we have discussed till question number 15, right? 15 and 16 also maybe. So now let us see question number 18. All of you see question number 18, and so first go through the question number 18 and we will discuss. So all of you go through question number 18. Can you see the screen?
Yes, sir.
It's NEET 2012. Such type of questions are also asked in JEE. So NEET and JEE mainly almost same.
So you're on mute.
Now am I audible? So I was asking, any of you have any idea how to solve this question? Anyone can give some clue? Krishna, any idea how to solve this
No,
question?
sir.
Maharaj, Samaira. So am I clearly audible, right? Today?
Yes, sir.
Okay. So let us see how to proceed for the question. Actually, the language of the question seems to be lengthy, like it's like 4 and 5 lines. But the question is very easy. It seemed to be difficult, but let us see how this is question is very easy. So first of all, the question says there is an electric field. Suppose we have assumed this direction of the electric, right? So this is the direction of electric field, and suppose it is E. Suppose this electric field is. Now it is saying that there is a dipole which makes angle theta with the direction of electric. Suppose the dipole is like this, and this dipole is making angle theta with the direction of electric. So this suppose this angle is theta. So now we have to see the torque and potential energy. So all of you have gone through the lecture of torque and potential energy. So if you remember, you may have gone through the formula. Can anyone say the formula of torque on a dipole in electric
P
field?
sin theta.
Correct. You have gone through the formula tau is equal to P cross T, right? And its magnitude is P sin theta. Okay. And you may have heard about potential energy in your class. In a regular class, which chapter is going on? First chapter or second chapter?
So third chapter.
Third chapter. So you may have heard about potential energy of a dipole in electric field. Can anyone say me the formula of potential energy? Potential energy is minus P dot E, if you remember, or it is minus P cos theta. Torque is P cross E and potential energy is P dot E. So this is nothing but only you have to see the formula. Now see the option. P sin theta and P cos. If you see the option A, which is correct as per the formula. So it's asked in NEET 2012. It's only a misleading question. There is a misleading term that is theta is equal to 90 degree in the question. But there is nothing to do with this angle. We have already considered theta equal to 90 degree when deriving the formula. When deriving this formula, when deriving this formula, potential energy, we have already considered potential energy equal to 0 at theta equal to 90 degree. So this is nothing new. We have already considered this one in derivation of the formula. So that is only extra information. Theta degree, the theta is equal to 90 degree. The question says that at theta equal to 90 degree, if you see here, the question says that theta is equal to 90 degree, take potential energy as 0, which has already been considered in deriving the formula. So you only have to do is write the formula. Nothing more. So have anyone having doubt, or all of you understood this question? Very easy question.
Yes,
Only
sir.
language is new. Okay. Now moving to the next question. So the correct option is A. Now see question number 19. So all of you go through the question number 19 and try to solve or give me any clue, then I will solve it. So all of you go through question number 19. Have all of you gone through this question number 19? So can anyone give me clue how to solve this question 19? Anyone having any idea? Anything you can say. Anything coming in your mind. How to proceed for this question. It's NEET 2011 question. AIPMT. So I will give you some idea like how to proceed. I have in previous class also I have given some idea how to proceed. Actually, what happened? We know the formulas, and but we don't know how to apply those formula or which formula to be applied. So how to decide which formula has to be applied for a particular question through this
Right.
example. Yeah,
So here we should use that dv by dx, right?
correct. You were doing correct. You're going in the right direction. We have to find electric field. So dv by dx is the correct method to do it. So I will explain you how to use that formula, how to arrive at a result to use that formula. So let us first see the question. The question has given electric potential and we have to find electric field, right? So what is the electric potential? In the question given that electric potential in a region V is equal to 4x, correct? So electric potential has been given and we have to find electric field at point 10. What has been asked in the question? We have to find electric field at a point 10. So in a region or a space, potential is given like this, and we have to find it. So what is coming in our mind? From the potential, we have to find electric field. So there must be a formula which has to relate between electric field and potential. So potential is given, and we have to find electric. So we have to remind the formula which is the relation between electric field and potential. So all of you may have heard about the formula E is equal to minus dV by dr, right? E is equal to minus
Yes.
dV by dr. Are all of you aware of this question? Of this formula? E is equal to minus dV by dr.
Yes, sir.
So now question arises, in this formula we have E is equal to minus dV by dr, but here we have x. So dr is actually general result for x, y, z. If potential is given as a function of x, you can write E is equal to minus dV by. So now put the values. So you will get equal to minus b by d. Write the formula v, which is given as 2x. So till now, have everyone got how we have written the formula is equal to dv by dx? Hanifa, are you getting how we are applying the formula? Krishna, Maharaj,
Yes, sir.
Yes, sir.
Samaira,
Yes,
are all
sir.
of you getting? Anyone having any doubt? Can ask in between also. If any doubt comes in the mind. So now what we have to do? Just take the constant outside. So 4 is the constant. So I will take it outside, and the inside will remain as d by dx of x square. So the differentiation of x square is minus 4 into what is the differentiation of x square?
2x.
Anyone? 2x. Correct. So it's 2x. So it will be minus 8x. So electric expression for electric field is equal to minus 8. This is the expression we have found from the potential. Now, what data has been given? Now see the data. We have given 102. It means, and electric field is only along x direction. So no use of 0 and 2. Only we have to use x. So put the value of x equal to 1. So we will get electric field as minus 8 into 1. Since we have to find electric field at this point. So this point. So for that we have to put the value of x as 1. So that will give you minus 8 volt per meter. Unit of electric field is also volt per meter. Newton per coulomb and volt per meter. Both are units of electric. The electric field will be minus 8 volt per meter along negative x. Till now, anyone having any doubt? Can raise your hand or ask. So, if you see the options, 8, option A says 8 along positive x-axis. No. 16 along negative axis. No. 16 along positive axis. No. What is the last option? C. 8 along negative axis. So, the correct option is D. 8 voltmeter, volt per meter along negative axis. So, everyone got how we got the answer T?
Yes, sir.
Yes.
Okay. So, this was how to, when you have given a relation between potential and when you have given a potential, so how to find electric field, this will be the general. If you have given in terms of y, similarly you can also proceed. Like if in the question we are given is equal to, suppose when the question says equal to anything, like suppose equal to 5y square. So in that case, what you have to apply is sorry, potential is given, not electric field. Suppose in the potential is given as v is equal to 5y square. So in that case, you will find electric field as dv upon d, and you can find it like 10. Integration will be. Similarly, suppose you have given v is equal to 5r square in a region. So in that case, you can apply the formula v is equal to dv upon d. So here you will put the value as 5r square, and you can get it as d by dr. This. So we will get 10. the differentiation of 5r square, 5 will come out, differentiation of r square will be 2r. So according to the data given in the question or according to the variation of the potential, you can decide which formula to be applied. If it is given in y square, you have to put dv by dv. If it is given in r square or r, you have to put dv by dv. Suppose in a question it is given that V is equal to suppose 5 volt. What will be the electric field? Suppose in a question potential is given as 5 volt. What will be the electric field? Anyone? Suppose in a region you have given the potential as 5 volt and you have to find electric field in that region. It's not a function of R, it's not a function of X. So how will you find? Anyone? Maharaj, what will be the answer? Krishna? Samaira, Hanifa, anyone? Potential in a region is given as 5 volt and you have to find the electric field. How will you find out? See, we have to apply the same formula. You can put it anything like you can apply dv by dr, you can apply dv by dx, anything. Suppose I write equal to dv by dr. So here dv by dr, what is the value of v? So value v is 5. So you put it as 5. So it's a constant. What is the differentiation of a constant? Anyone? What is the differentiation of a
Zero.
constant? Correct. Differentiation of a constant is 0. So electric field is 0. So if in any region potential is constant, if potential is constant, electric field is always 0. In any region, if potential is constant, electric field will always be 0. All of you got this?
Yes, sir.
Yes, sir.
So you have to proceed. Okay. Now come to question number 20. I think we have discussed this question 20, right? Anyone of you remember or not? Have we discussed 20? If not, go through that. Question number 20. Everyone go through question number 20. NEET 2010. Have all of you understood the question? Question number 20. Saying that the electric field at a distance of 3r by 2 from the center of a charge conducting a spherical shell is E, then electric field at a distance of r by 2 from the center. So let us see two times what it says. What question is saying? It's saying that Suppose we have a conducting spherical shell and electric field from the shell, from the center of the shell at a distance. Suppose we have a point P and its distance is 3r/2 from the center. And at this point, electric field is E. The value of electric field is given as E. Suppose this is center. Now, using this information, we have to find electric field at a point, suppose this point P, which is at a distance of r/2 from the center. And this is a conducting shell. Conducting shell. What is the question number? This is question number 20. Question number 20. NEET 2010. So have all of you understood the question? What it is saying? It is saying
Yeah.
that at a point P, which is at a distance of 3r/2 from a charged spherical shell. Suppose charge on the shell is Q. And here the electric field is E. Now we have to find electric field at a point which is at a distance of R. So any clue from anyone how to solve this question?
Sir, can you show the question again?
Yeah, you can see the question options also.
Sir, we should use that formula for electric field inside a spherical shell.
Okay. Anyone else? So you're saying that you can apply. I think you're right to some extent. But let us see what formula. What is the formula for electric field into shell? We have a formula. We have also discussed in the last before the last class. What was that? E is equal to KQ by R KQ upon R square if R is greater than equal to R, and we have considered E equal to for a shell, conducting shell, equal to 0 if R less than R. So in the given question, what condition has been satisfied? What condition met for the given question? The given question comes under which of the following case? This case or this case?
Second case.
Correct. It comes in the second case. Since R equal to R/2, it means R is less than R. It means the point is inside the shell. If any point inside the shell, whether it is R equal to 0 or whether it is R is equal to R/5 or whether it is R equal to R/3 or whether it R equal to R/2, in all such cases, if R less than R, E will be 0. So it's only the value given as value of electric field as E is actual a misleading information or to mislead the student or extra information. There is no use of this expression. You can directly say that if it is given or not given, you can directly say that electric field is 0. Got my point?
Yes, sir.
All of you, anyone having any doubt? Maharaj, Samaira?
No, sir, no doubt.
Okay, so electric field is 0 since the given point is inside the shell. Moving to the next question. See question number 21.
So which question?
Question number 21. 21st question. NEET 2009. So all of you go through question number 21, then give me some clue how to solve. So had all of you gone through this question 21? Can anyone give clue or some anything comes in any concept which you can relate to this question or anything coming in your mind how to solve this question, how to proceed? The question says the mean free path of electrons in a metal is 4 into 10 to the power minus 8 meter. Okay. The electric field which can give an average 2 electron volt energy to an electron in the metal. So if you see in the question, two quantities has been given. First, there is a distance. Mean free path means there is some distance has been given, and there is a energy. There is a energy, electron volt. There is a distance, and we have to find electric. What we have to find? So let us understand it. To like in a region we have given, suppose an electron travel in a metal, you can say randomly like electron moves like this, and its mean free path. Actually, what is mean free path? Actually, it is the distance between. Anyone know mean free path? What is the mean free path? Actually, when an electron travels through a metal, it has collisions with the other atoms or molecules. So the distance between two successive actually when an electron moves through a metal, it collides with many molecules, nearby molecules, atoms, and something. it collides frequently. So minimum distance between two successive collisions is known as mean free. Minimum distance between two successive collisions. But here is nothing to do with the definition. Only you have to treat the mean free path as a distance. So in the question, it's saying that mean free path is O into 10 to the power minus 8 meter. So you only treat it as a distance which electron travels. So suppose in a metal, the electron travels to a distance 4 into 10 to the power minus 8. Nothing more. You treat this mean free path as distance. Nothing to do with the name. Distance is distance. So you treat the mean free path as a distance. They have given this distance. Now what is given? The energy. Energy is given as 2 electron volt. Energy of the electron is given as 2 electron. So energy means what? Energy actually relating to potential. Energy means potential. If you may have heard in chapter 2, when you multiply potential, what is the potential? Potential is actually potential energy per unit charge. So how you get energy? When you multiply potential by a charge, you get energy. So here energy of electron is given. It means actually potential is given. Correct?
Yes, sir.
Till now, have everyone got this point? In which direction I am going? And you have to find electric field. You have to find electric field. What it means? Again, the same story. Like you have given potential, you have given distance, and what you have to find? So apply the same formula. E equal to dV by dt. This formula seems to be very small formula, but it is the remedy for many problems. Number of questions can be solved by this equation. Whenever you have a relation between distance and potential, you just merely apply this formula, you will get the result. Now apply this formula, you have to find the electric field, potential is given, distance is given. So how you can apply? You just write dV. dV means actually potential. So dV by dr, you can only write like this also. dV is actually potential. You can write it as a potential and dr can be written as distance. So you can write it. Actually dV means for change in potential and dr means change in distance or the distance traveled. So potential can be written as energy per unit charge, and R into distance. So you will get result E equal to, what is the energy? It is given 2 electron volt. What is the value of energy? It is given 2 electron volt. And what is the charge on electron? E. We all know that charge on electron is E. And what is the distance? Distance is given as 4 into 10 to the power minus 8. So put the values, you will get 2 upon 4 into 10 to the power minus 8. So you will get 1 by 2 into 10 to the power 8, and it's come as 0.5 into 10 to the power 8, or it may be written as 5 into 10 to the power 7 volt per electric field is volt. So anyone having any doubt till now? Or we got 5 into 10%? All of you understood this question? Any
Yes.
query, any doubt? Okay, so now let us see which option match with this. C option C, 5 into 10 to the power 6. So the correct answer is C. All right, okay. Anyone, any doubt? Should we move to the next question? So see the importance of this question. In last 2 or 3 questions, yes, we are applying the same. So if you see in a particular chapter, like if you see the chapter 1, there is not more formulas. Same formulas will be repeated again and again in number of questions. So if you see chapter 1, hardly there are how many formulas? You have Coulomb's law formula for force, and from this you get electric field. Same formula like F is equal to Q1 Q2 by R square K. Formula for force is Q1 Q2 upon R square. Same type of formula you get for electric field KQ by R square. So if you only remember the formula for force, you can automatically go for it. And from this similar type of result is for shell also. For shell you see same formula E is equal to PQ by R, not new. And only the other formula is E is equal to dV by D. E is equal to dV by D. This is one formula. So this is this. If you remember one formula, Coulomb's law, second formula is equal to dV by dr, and some 2 or 3 results of Gauss law, which we have seen, like E is equal to sigma by epsilon naught for sheet of charge, and some like line charge by 2 pi epsilon naught lambda by. So if you hardly there are 4 or 5 formulas. If you remember all these formulas, or if you understand, don't even remember. If you understand the thing, automatically you will remember the formula. So if you have the concept of these 4 or 5 types of concepts or 4 or 5 types of formula you are aware of, you can solve each and every question. If you see till now, we have solved almost 20 to 25 questions. In all the formulas, in all the question, only we have applied these formulas, like electric field, Coulomb's law, dV by dr, or some kind of like dipole also like dot is equal to P cross E. Only these formula has been repeated. Are all of you agree with this? What I am saying? So
Yes,
there
sir.
is not much new things to learn or something. Things will be repeated. If you understand this, you can easily solve chapter. Even chapter 2 questions. Same is related with potential, and potential energy comes with the field. So that is the thing. Okay. Now see question number 23. It's a NEET 2007 question. And it's also such type of question asked in JEE MEB. So go through question number 23. Anyone having any voice issue? Am I not audible? Please tell me. Am I audible clearly? Samaira, Krishna?
Yes, sir.
Yes.
Okay, so let us see the question number 23 now. It says what it says. There are point charges plus q minus q and then plus q which are placed at points x equal to 0, y equal to a and z equal to. So first we will draw the axis x y z axis, then we will see uh, how these charges are situated. So let us see. See those who are having issue in voice or unable to hear, I think they have some internet issues because some of the students, if some of the students can clearly hear me, so I think this is not problem from my side. So maybe there can be issue from your side also. If everyone cannot hear, then I can admit that this is problem from my side. Okay. So now let us move to the question. So let us draw the axis. Like suppose we have axis like x, y, and z axis. So suppose we have axis like this x, y, and z axis. So this is x axis, this is y axis, and this is z. Now what question says? It says that there are point charges plus q. Plus q is at x equal to 0. So like x equal to 0 means origin. So suppose this is here we have the point charge plus q. So plus q charge is placed at the origin. Okay. Then there is a charge minus q at y equal to a. So according to question, there is a suppose we have a point charge here minus q. The point charge minus q is here. Point charge minus q is here. Then we have point charge plus q at z equal to 0. So 3 point charge plus q is at x equal to 0, y equal to a, and z equal to 0. First charge was at y equal to a. So first charge is here. Let's say this is first charge. Then second charge is placed at x equal to 0, y equal to 0, and z is equal to 0. So at the origin we have minus 2, not plus 2. Sorry. At the origin we have charge minus 2. So in the question given that first charge is placed here, then at the origin we have minus q, and then other charge plus q is at x equal to a. So another charge is here, like then plus q charge is placed at here. Okay. Then magnitude and direction of electric dipole moment. So we have to find net electric dipole moment. So according to the question, there are three charges which are placed at the position shown in the figure. Now we have to find net electric dipole moment of the configuration. So first we have to find how dipoles are formed. So can anyone give some clue how to solve this question? We have three charges. So can anyone say how the dipoles are formed here? Can you identify the dipoles?
So
Anyone?
the charge at y-axis is positive q, right?
Let me check. Yes, yes, correct. Charge at y-axis. This one is positive. There is only one negative charge. This one is. So anyone can give any clue?
So the direction will be from minus q to plus q, like from origin to y-axis and origin to x-axis.
Okay, so you are saying how many dipoles are there? One dipole or two dipole? You are
So I
going
think,
in the, yeah.
so I'm
See,
not sure.
you are going in the right direction, but here you are correct that the direction is along my x-axis. So here actually two dipoles are formed. If you see, one dipole is like combination of this charge and this charge, and its dipole moment is along minus charge to plus. Let us see its dipole moment P1. And another dipole will be formed along this direction from minus q to plus q. Let us see its dipole moment. So actually, if you see here, we have two dipoles. Here we have two dipoles. One is here we have two dipole like this. One dipole is like P1 is along this direction and P2 is along this. Correct. So how we can find resultant dipole? Resultant dipole will be, since these two dipoles are perpendicular to each other, so resultant dipole will be along this dipole moment P will be along the angle dividing both the dipole. You may have heard about, you may know the vectors, so you have some concept of vectors. If there are two equal vectors, then the resultant vector is along the line which is dividing the angle between the two. You know this concept, right? You may have studied in class alone. If there are two equal vectors, you may have seen like this. If you have a vector A, then again vector A. So resultant is dividing both the vectors, right? And at 45 degree with the first one. So similar is the case here. Here dipole moment, since if you see the dipole moment, what is the dipole moment? We know that P is equal to Q into 2A, the distance. So here distance of both the dipole is same. Here also A, here also A. So what will happen is that magnitude of P1 will be equal to magnitude of P2, and that will be equal to Q into A. Agree with this or not?
Yes, sir.
Since here the distance between plus charge and minus charge is A. So here the dipole moment will be Q. So that will be Q into. And both the dipole moments are equal. So resultant will be obtained like this. Suppose we say it as P. Suppose we say this dipole moment as P. P1 equal to P2 equal to P. Then what will be the resultant vector? We know that if two vectors are perpendicular, the resultant vector. Here the resultant dipole moment will be given by this. Since two vectors are perpendicular to each other, so it will be P1 square plus P2 square. Since P1 and P2 are equal, so we can say it is P square plus P square. So the resultant dipole moment will be root 2P. And if you put the value root 2, what is the P? Q into. So it will come as root 2 into Q into. Obviously, it will be along this direction, along the line joining origin. So the dipole moment will actually the resultant dipole will pass through origin. And if you see, it will extend like this. This point will be A and A. Correct? This direction is also A and this is also A. So it will pass through origin and extend up to the point A and A. So all of you understood this one, how we got root 2 QA and the direction. Anyone having doubt, please ask. It's nothing, just a formula for resultant vector, nothing more than P square plus P. So Krishna, have you got this?
Yes.
Samaira, have you understood?
Yes, sir.
Okay, so now see the options. Which is the correct option? Can you identify? Which one is the correct option?
Sir, I think A.
Correct. A is the correct option. Root 2 QA along from x equal to 0 to x equal to a and from y equal to 0 to y. Here no role of z because since no charge is along z, all the charges are in xy plane only. So all will be in the xy plane only, nothing is along z. Maharaj, I think you have net connection issue, right? Sometimes you got connected and disconnected. Maharaj, your net is, I think, not stable there. We may have some voice issue because of your net connection. From my side, the voice is continuous. Okay. Okay. Now moving to next question. So all of you go through question number 24. Very easy question. Only you have to remember the formula of type. So look, look into question number 25. All of you go through question number 20. Actually, in 2 or 3 class, there was issue in last class, but now since 3 or 4, actually previously I was using mobile connection, but now I am using Wi-Fi connection since 2 or 3 days. So there will not be issue from my side. This connection is mostly stable. So in the initial 1 or 2 classes, you may have faced some issue, but I think now. If any issue with the feeling sometimes like in writing or something, then ask me that time. If you couldn't understand anything like calling, this is a kind of pen tab or digital writing. Writing is not much as we write on the board. So if you feel any time issue in handwriting or something, you tell me that at this point I couldn't understand or I couldn't visualize, so I will dictate it. So my point of view is never go home or after class, never you should have any doubt in your mind, like you couldn't understood this thing or due to writing or due to voice, I couldn't hear that thing. So whether going with a doubt at your home, ask me at that time. I want that if you feel anything, you ask that time. You clear your doubt. Don't go with a burden of doubt in your mind. Okay? Try to resolve anything in the classroom. I'm here to solve your theories, solve your problems, not to give you problems. Okay. So go through question number 24. It's based on dipole. So anyone can give idea how to proceed for this question?
Sir, electric field of a dipole on an due to an axial point, sir.
Yes. The question says the electric field intensity due to a dipole of length 10 centimeter, 10 centimeter and having a charge of 5 microcoulomb at a point on the axis at a distance 20 centimeter from one of the charges in air. So the medium is air and we have to find electric field. You know, here you can see it is saying that at a point on the axis means you can conclude from here that you have to find electric field on the axial point, right? So we have to find electric field intensity. So let us see. First of all, the question is how to proceed. Let us see how to proceed and how to come at the characteristic. First, see we have to deal with the dipole, correct? So first there is a dipole. It is clear that there is a dipole. You know what is the job of a teacher? You know, a teacher cannot teach you every question or every problem. What a teacher can do, a teacher can explain you how to solve the question, how to proceed for a given question. So I am trying with that. I am trying to explain you if you find a question, how to connect you with the correct formula, how to connect you that question with the concept. So that if you find any similar kind of question, you can apply the same. So here if we see the question is asking or the question is saying about a dipole. So first of all you identified that this question is based on the dipole. First thing you have identified. So just you will write dipole. What you will do? to try dipole. Now see the question saying electric field intensity. It means it has been asked, something has been discussed about, something has been given about electric field intensity. So now we know that due to a dipole there are two kinds of electric field. One is axial and one is equatorial. We already know equatorial. So can anyone tell me the formula for electric field on axial point of a dipole? What is that?
So K into 2P by RQ.
Correct. K into 2P by R. You can write the magnitude only. And what is the formula for electric field on equatorial point?
K into P by RQ.
Very good. K into P by R. So these are two formulas. Axial electric field is twice of equatorial. Now in the question it is saying that at a point on the axis at a distance of 20 centimeter, you have to find the electric field. In the question it is given. So in the formula, now you have to see what things you require to find the electric field. So the electric, we have identified that we have to find the electric field on the axis, and this formula is K into 2P by. But and here we know the form value of K, that is 9 into 10 to the power 9. R is also given in the question. It is given that we have to find electric field at a distance of 20 centimeters. So this is also okay. And if you see the options are given in SI units. So if options are given in SI units, you always convert the given quantities in SI units. So given distance is in CGS unit, 20 centimeter. So you have to convert it into meter. So put the value of R in meter. Don't forget that. So you have to put it like 20 into 10 to the minus 2 cube.
Sir, R
Now,
should be the distance from the center of the dipole to the axial point, right? But this is
yes,
like from one of the charge to the axial point, sir.
let me check. At a point, the electric field intensity due to dipole of length itna and having charge itna at a point on the axis at a distance 20 centimeter from correct from one of the charges. Yes, you identified the correct thing. The in the formula the R is from one of the charges, but here the 20 centimeter is from one of the charges in air. Okay. Okay, I will explain you how the value which I have written is correct. I will explain you. Okay. Then due to dipole of length 10 centimeter. The length of the dipole. Okay. So first draw the dipole. Here we have already drawn, and length of the dipole is given as 10 centimeter, correct? And the distance on the axis of the dipole is, suppose from this chart, suppose we have taken from this chart and this point is like here. Okay. Let us see, suppose this point is P like here and its distance is given as 20 centimeter, right? 20 centimeter
Yes.
from one of the chart. We don't know from this chart or this chart. It's not given that. Actually, there is a problem here. In this question, we have to be very careful. This question is not so easy. You know, there is one thing. If you see, can we apply this formula here? Can anyone Is this formula applicable here? Here we have written the formula this. Will this formula be applicable? While applying formula, you also must be very careful. Here we cannot apply this formula. If you see, can anyone say me how, why we cannot apply this formula? Here we cannot apply this formula. Actually,
Because
you
R is
pointed
not.
no, you pointed out very correct thing that it is from the one of the chart, but while writing this on here on the board, I also identify one of the concept which should be applied here. Here directly we cannot apply this formula. I will tell you why. Let us see. In this formula, if you remember, you have used an assumption of R is much less than A. Have you remember that? In this formula, we only this formula has been derived by using this concept when R is much greater than A. Means the distance of the point must be much greater than the separation between the charges. Right or wrong? Have you remember this
Yes, sir.
condition? If you see here, this distance is not much less than as compared to this. Here you see, R is just twice of the separation between the charge. So R is comparable of A. R is comparable of A here. R is not much greater than A. Here this condition is not satisfied. So what you have to do is, you have to apply direct method to find the electric field due to 2-point charges. We will find first the electric field due to plus Q charge by using E is equal to KQ by R square. Then you will find electric field due to minus Q charge by applying KQ by R square. Then you will subtract from larger to smaller. Getting my point? You cannot use this formula directly here. This formula is only applicable if this condition is satisfied. Are all of you getting my point?
Yes,
Yes,
sir.
sir.
Okay. So now there is a twist. So this is neat question. This must be not such an easy question to that you can directly apply for. There was a concept hidden in it. So what you have to do now? You have to do first to draw the anchor. Like this. You know what happens in exams, generally NEET and JEE exam, first option will be from the misconstruction of this. Generally, when we frame question, we know that where this student can have some misconception. And first push and first option is generally based on that misconception. You will write that formula, you will get result, and first option will be based on that. And generally, student in hurry think that this option is correct, but generally sometimes that may become wrong. So you have to check it properly by picking option A. Option A is very dangerous. When you are getting option A as the answer, be careful. So here minus Q and plus Q. Now suppose we have this point P and this distance is given as 10 centimeters. And we have to find electric field at the point which is situated at 20 centimeters. So what you will do, you will apply general formula to find electric field at point P. You will first find electric field due to plus charge, then you will subtract the electric field due to minus charge. Getting my point?
Yes,
So
sir.
what will be the value of electric field due to plus charge? K into, you can put plus Q by R square. R is, suppose this, I have assumed that it may be, this point will be along minus Q charge. It can be along anywhere, like towards the plus charge, or it may be here also. So result will be same. So I am assuming it towards right side. So KQ by, what will be the value of R? It's 20 into 10 to the power minus 2. And then we will put K into K, or we can put it like this, K minus Q by, what is the R now? Now the distance will be from this point, right? So total distance will become 30. Getting my point?
Yes, sir.
Distance will become 30 into 10 to the power. So now putting the values. Now putting the values, I will take KQ outside. So I will get, and also I can take 10 to the power 4 minus side. Inside will be 10 to the power minus 1 also. So I can take 10 to the minus 2 common. So I will get it as 1 by 4 minus 1 by 9. Everyone got this? How I simplified this one? In bracket, if you see in a bracket, it will remain 10 to the power minus 1, because here 20 into 10 to the minus 2. And then square will be 10 to the minus 2. So I have taken 10 to the minus 2 outside. Here you can see. So the inside will be like this. Now put the value as case 9 into 10 to the power 9. So
So
here,
minus should not be considered, right?
why not minus will be considered? Both field are in, if you see in physics also, here the direction are in opposite. Either you take, if you see the direction of electric field is opposite because of both the charges. So you must take minus sign. If you see at point P, if you see at point P here, where is the direction of electric field due to negative charge? It will towards this E minus. If you see the electric field due to plus charge will be towards right. I'm right or wrong? So we must
Yes, sir.
consider minus. Both are in opposite direction. So here we will get result as 9 into 10 to the power 9. And what is the value of Q? Charge is given as 500 into 10 to the minus 6. 500 into 6 divided by 10 to the minus 2 into 5 upon, you will get 36. So solving it in the next page, I will get it as 9 into 10 to the power 9 into 5 into 10 to the minus 4, 5 into 10 to the minus 4 divided by 10 to the minus 2, 5 into 5 divided by. So now what will be its value? It's 9 into 10 to the power 5 into 5 into 5 divided by 56 into 10 to the power 9 into 10 to the power 5, 10 square. So it will be 9 with 4. So you will get this 25 divided by 4 into 10 to the power 7. What will be its value? It will be now 6.25, right? So 6.25 into 10 to the power 7 Newton per Coulomb. So C, option A is the correct answer. Have all of you got? So you
Yes,
cannot use directly. If you will use directly that formula, you make it wrong. You solve it by using that formula. So it's your homework. You directly solve by that formula, you will get wrong result. Okay. So you have to use general method, not dipole direct formula. You
sir,
may,
I did direct from the, sir. I got 2.6 into 10 power minus 8.
okay. Yes. So there is no option like that. Okay. So we cannot use it. We have to be very careful while applying that. Here the condition is not met, so you have to apply the general formula. And if you see that result has been derived from using general formula, right? We have used the general formula and then we use the given condition, this condition, and then we come to this. Got it now? So the basic thing is the general formula, which is always correct. So if such conditions are there, are much greater than a condition is not satisfied, you have to use this. So everyone got this one? Anyone having any doubt? This was a good question, and this can be, many of the students can be misled and apply that formula and they make it wrong. So anyone having any doubt, I will wind up here for today's class, and I will give you assignment and go to the portal and you can find your previous assignments also. For today's class, I will also put some assignments. So it's better you get all the questions from the portal and you try to practice those assignment questions. So, all right, we are winding up today's class. Anyone having any doubt can ask, or otherwise we can log off.
No doubt, sir.
Okay.